It is simply about networking protocols, and today we're talking about OSPF LSAs, link state advertisements. Standard that describes this behavior is the same, RFC 2328. In this video, we are talking about OSPF stub and not-so-stubby areas, router LSAs, network LSAs, summary LSAs, and autonomous system external LSAs. As you remember from previous videos, topology, OSPF topology is built from autonomous system, border boundary devices, OSPF area border devices, OSPF area dedicated devices, links between them, physical and virtual links, and networks that actually build OSPF area and autonomous system. So when traffic is traveling, it's traveling through some autonomous OSPF areas inside the autonomous system. So if we know that for any reason, due to physical limitations or due to configuration limitations, there will be no transit traffic in some area, we can call this area as a stub area. It means that traffic that generates inside the area is dedicated to devices within area, or if it's going out through one device, probably several devices. This is more complicated, but anyways, through one device. And external traffic that goes into the area is dedicated to devices within this area only, there is no transit, then we call it stub area and configure as stub area. It means that all routers within this OSPF area supposed to know actually one default route to the area border device, area border router. Then all other traffic starts traveling from this particular point. And it means that we should not have entire OSPF table on devices within this OSPF area. We should not recalculate this entire OSPF table. We can use less powerful and more cheap devices, more cheap routers within this area to maintain it, to operate traffic and operate OSPF, because OSPF table is tiny comparing to full table that should supposed to be operated by all other devices within autonomous system. So cheap, simple, and that's it. No transit. Backbone area. Backbone area is contained of area border routers and autonomous sister boundary routers and links between them, physical or virtual links. All backbone area devices or backbone area routers supposed to be connected to each other within autonomous system and within area. So devices that belongs to some area connected to each other within this area. Sometimes we cannot for any reason define virtual link between devices. Then we can include into backbone area area dedicated device that only belongs to some specific area. It is not border router, and this device is included to maintain this connectivity between routers of backbone area. And now let's talk about, so this is important because all the routing happens in the way like traffic goes to, as you remember from previous video, goes to border router, and from border router it is being routed to another area or to the boundaries of autonomous system and goes out, and then routed inside some specific area or another autonomous system. So we have area border boundary device, whatever you call it. And for example, we have, let's say, pretty stub area where communication with other areas of this autonomous system is very similar to actual stub area, but also we have, for example, autonomous system boundary device. But important, most traffic that goes out goes through this device from the area, and most traffic that enters device is dedicated or targeted to devices within this area. So this is tiny amount of transit traffic within area. Then we can call this area not-so-stubby area. Again, we have less demanding OSPF table to maintain, and we can use more cheap and less powerful devices within this area to maintain, manage, and operate the traffic. Now, let's talk about LS types. LS type 1 router LSA. Those are type of LSA that required and sent from router to router only to neighbor routers within specific area. It means that area dedicated device sends it to all the neighbors within this area. Autonomous system boundary device sending it to the area where it belongs within our autonomous system by OSPF instance that operates in this area and through the interfaces that belongs to topology within this area through physical and virtual links. And in case we have area border device, you remember from previous video, in case device belongs to multiple areas, on this device supposed to run OSPF instances per area. So we have OSPF copy instance for each area, and we have intra-area internal area topology that includes several interfaces of this device that belong to the specific area. Router LSAs are sent by the instance through interfaces that belongs to specific area. Next, LS type 2 network LSA. We have a network with devices and we have routers, and one network can be managed or connected to multiple routers. And for any reason we need to transmit the information about network status, router status, possible connections, and all those things to neighboring devices that are connected, that are within our area, OSPF area. Then network LSA is being sent by dedicated router. So in case of network LSAs and multiple devices connected to the same network, devices electing dedicated router and backup dedicated router who waits for dedicated to blink, to take his place. But anyways, only dedicated router generating network LSA for specific network to reduce the chaos and reduce amount of control traffic. LS types 3-4, summary LSA. Summary LSA are LSA that informing devices, routers within some specific area about routes to devices in other areas. This is LS type 3. Routers to other devices in other areas that are generated to devices in specific area are LS type 3. Routes to autonomous system boundary devices are LS type 4. They also being sent within some area, so each device that participating in this area knew this root knew the device that is boundary to autonomous system and can, manage the root. The thing is that those LS types 4 are not sent within stub area, because as you remember previously, we told that all devices supposed to know this basically default route to the area border device, and that's it. So they don't need to manage entire path. No transit traffic expected. LS type 5, external LSAs. Those are LSAs that informing devices within area about path in other autonomous systems and are generated by devices that are autonomous system boundary devices within specific areas. They being forwarded to another areas by boundary devices, except LS type 5 is not forwarded again into stub area because we don't need it. Our devices know default route, maintain it. We don't need entire OSPF table to be maintained in stub area. This is how the OSPF table is reduced. This is how amount of calculations is reduced. This is how we make cheaper and less powerful devices still useful for OSPF and routing and management. As for Not-So-Stubby Area, it has some specific. Autonomous system boundary device generates into Not-So-Stubby Area LS types. They are still autonomous system external LSAs, but they are type 7. So we know we announce in some areas not so stubby devices know about that and generating them as 7. When they reach area border device, they are being transmit further as LS type 5. But when we're receiving LS type 5 to the border device, they are not transmit into not so stubby area, telling about another distances to another routes to boundaries of our autonomous system, because again, remember, not so stubby area, traffic that's supposed to go out of our autonomous system goes through specific device. This is why it's not so stubby, but still stubby. That how it's simple is. Thank you. Have a great day.